Hi everyone, my name is Jarul and welcome back to our channel. Today we'll be doing the second part of the chapter Chemical Reactions and Equations of Grade 10 CPC Science. And today I'll be teaching you how to balance chemical equations. Now, balancing chemical equations is an important topic not only for this chapter but for the whole of chemistry, so make sure you pay attention and understand how exactly it's done. Now let's get to it. Now, before I go on and show you how to balance chemical equations, you may be wondering why we need to balance chemical equations and what this whole balancing business is about. Well, to understand this, you need to revisit the law of conservation of mass. The law of conservation of mass states that mass is neither created nor destroyed in chemical reactions. What this means is that the total mass of all the substances combined at the beginning of the reaction will be equal to the total mass of all the substances combined at the end of the reaction, no matter what chemical changes these substances have gone to, and no matter what new substances may have been created during the chemical reaction. Now, this also means that the mass of any one element at the beginning of a reaction will be equal to the mass of that same element at the end of the reaction. So we see it's not only the total mass of all the substances that doesn't change, it's also the individual mass of each element that remains the same from the beginning of the reaction till the end of the reaction. Now, we see that a lot of times when we represent chemical reactions in the form of equations, this rule doesn't really get fulfilled. To explain this further, let me use an example. Magnesium plus oxygen gives us magnesium oxide. Now, what we need to do is to look at this equation and see if the mass of each element is the same on the left-hand side and on the right-hand side. To do this, you need to know that each atom of each element has a fixed mass. Like magnesium, each atom of magnesium has a fixed mass of 24 units. Similarly, each atom of oxygen has a fixed mass of 16 units. Now let's look at this equation. So on the left hand side we see that we have one atom of magnesium, and as I've told you before, each atom of magnesium has a fixed mass of 24 units. On the right hand side as well we have one atom of magnesium, and then again 24 units is the mass. So the mass of magnesium on both sides of the equation is the same. Now let's move on to oxygen. Oxygen, as we can see over here, has two atoms. And since I've told you that each atom of oxygen has a mass of 16 units, two atoms of oxygen would have a mass of 16 into 2, 32 units. So on the left hand side, oxygen has a mass of 32 units. However, on the right hand side, we have only one oxygen atom, and this has a mass of only 16 units. Over here, we see that the mass of oxygen is not the same, and the law of conservation of mass is not fulfilled. If it were to be fulfilled, the right hand side would also have two atoms of oxygen, and this is exactly what we need to balance over here. We need to balance the number of atoms on each element on both the sides of the equation to make sure that the masses of these elements are the same. Now, this is an example of an unbalanced equation, and now we know what we have to do to balance it. However, before I show you how exactly to do it, let me show you an example of a balanced equation. So this is it. Zinc plus sulfuric acid gives us zinc sulfate plus hydrogen gas. Now, to find out if the masses are equal on both the sides of the equation, we don't actually need to know the atomic mass of each element. We don't actually need to know the mass of one atom of zinc. All we need to look at is the number of atoms of each element, and we need to check whether they're the same on either side. So let's do that right now. Over here we see that we have one atom of zinc on the left hand side, one atom of zinc on the right hand side, two atoms of hydrogen on the left hand side, two atoms of hydrogen on the right hand side, one sulfate ion on the left hand side, and one sulfate ion again on the right hand side. So we see that everything is equal and in balance, and this is an example of a balanced equation. However, if an equation is unbalanced, we will be needing to balance it, and I will show you how to do that in the next slide. Now, to balance chemical equations, what we have to do is add coefficients or numbers at the beginning of the elements in the places where I've put dashes. Before I go on forward, let us take some time and look at this chemical equation. In this chemical equation, we see that water has been broken down into hydrogen and oxygen. This is the chemical equation for electrolysis of water, and we see that this chemical equation is unbalanced. On the left hand side we have only one atom of oxygen, while on the right hand side we have two atoms of oxygen. So to balance this chemical equation, what I'm going to be doing is I'm going to be adding numbers or putting numbers at the beginning of the elements in the places where I've put the dash. Now for example, let me put a 2 over here. So instead of one molecule of water as it was previously, I now have two molecules of water. And since water has two elements, hydrogen and oxygen, to find out the number of hydrogen atoms, let's say, all we have to do is multiply the coefficient with the subscript. So 2 into 2 is 4, and we see that with two molecules of water we get 4 atoms of hydrogen. Now similarly with oxygen, all we have to do is multiply the coefficient with the subscript. And since we have nothing over here in the subscript, it means that we have one atom of oxygen. So 1 into 2 is 2, and we have two atoms of oxygen for two molecules of water. Similarly, I can put any number over here. Let me put it 3 over here in front of hydrogen. So this says that instead of two atoms of hydrogen as I had before, I now have 6 atoms of hydrogen. 3 into 6. 3 into 2 is 6. And now I have 6 atoms of hydrogen. So for the next thing, let's pretend that this 2 in the oxygen doesn't exist and it's only one single atom of oxygen. And if I put a 4 over here, let's say, it would mean that instead of that one single atom of oxygen that I had before, I now have 4 atoms of oxygen. Now, enough of pretending and me giving you examples. Let us get to solving the actual chemical equation. Now, the first step to solving any chemical equation is to write down the number of atoms of each element on the sides of the equation. Now over here we see on the left hand side we see that we have 2 atoms of hydrogen, 1 atom of oxygen. On the right hand side we see that we have 2 atoms of hydrogen and 2 atoms of oxygen. Now we see that also the hydrogens are balanced. As we've said before, the oxygens are not. And what we're going to do is try to balance the oxygens first. So on the left hand side we see that we have only 1 oxygen. And to balance that, what I'm going to do is multiply the left hand side oxygen with such a number that it would equal the number of oxygens on the right hand side. And now obviously 1 into 2 would give me 2, and that's the number of oxygens on the right hand side. So I'm going to be multiplying the left hand side oxygen with the number 2. And since oxygen isn't available as a single element and it's available in the molecule of water, I would have to put a 2 over here before the molecule of water. Now over here we can see that oxygen is balanced off. I have 2 atoms of oxygen on the left hand side and 2 on the right hand side. However, this chemical equation isn't yet balanced because now since I put 2 atoms of oxygen, instead of hydrogen, the number of hydrogen atoms have changed and it has become 4 atoms of hydrogen. So now all I have to do is multiply the right hand side hydrogen with a number that will give me the number of oxygens as it is on the left hand side. And obviously it's really simple math. The number is 2. So 2 into 2 is 4. So now I'm going to be putting the 2 coefficient in the beginning of the hydrogen on the right hand side. And now we can see that this equation is balanced, and let's just take a quick look and make sure that everything is actually balanced off right now. So over here we see that hydrogen 2 into 2 4, that's balanced, and 2 into 2 again 4, so hydrogen is balanced. So 2 into 1 oxygen is balanced, and 2 over here, so oxygen is balanced as well. Now we can say that this chemical equation is finally balanced, and now let's move on. Now I've solved one chemical equation in front of you, and I hope you got the basic idea of how it works. However, balancing chemical equations isn't that easy, and especially since that was such a basic chemical equation, what I'm going to be doing now is giving you examples of unbalanced chemical equations, and I'll be solving them in front of you so you understand how it works and you'll be able to solve even more complex equations all by yourself. So now the first example that I have for you today is this. Copper oxide plus carbon gives us copper plus carbon dioxide. And as I've said before, the first step to solving any chemical equation is to write down the number of atoms of each element on both sides of the equation. So let's do that really quickly. On the left hand side we have 2 atoms of copper, 1 atom of oxygen, and 1 atom of carbon. On the right hand side we have 1 atom of copper, 2 atoms of oxygen, and 1 atom of carbon. So as we can see that the carbons are balanced, however the copper and oxygens are not, and we need to balance them. We can start with any one, and right now I'll be balancing copper first. So on the left hand side we have 2 atoms of copper, and on the right hand side we have only 1. So as I said before, what we need to do is to multiply the right hand side copper with such a number that it gives us the number of coppers on the left hand side. So that number is obviously 2 right over here, and what I'm going to be doing is writing 2 over here on the right hand side, and copper is balanced, at least for now. Now let's move on to oxygen. On the oxygen it's kind of like the reverse case as it was in copper. On the left hand side we have 1 atom of copper, and on the left hand side we have 1 atom of oxygen, and on the right hand side we have 2 atoms of oxygen. So to balance this, I would be multiplying the left hand side oxygen with 2. And since just like the previous example, we don't have oxygen available as a single element, and it's in the copper oxide molecule. So nevertheless, I'll just be writing a 2 over here in front of the copper oxide molecule over here. And you might think that this equation is balanced right now, but however you need to look again, because since I've added this 2 to the copper oxide molecule, the number of copper atoms has changed from 2 to 4. So this isn't 2 anymore, it's actually a 4 over here. But not to worry, all we need to do is multiply the right hand side copper with the number that will give us the number of coppers on the left hand side, and that number is again 2. So 2 into 2, 4. So basically we have a 2 over here, and we need to multiply this 2 with another 2, which gives us 4. So instead of 2, I'll be writing over here 4. And let's just take a quick look and see if everything is balanced right now. So we see that copper, 2 into 2, 4, 4. So coppers are balanced on both the sides. Let's look at oxygen now. 2 oxygens on the left hand side and 2 oxygens on the right hand side. Oxygen is balanced as well, and carbon was always balanced. So now we can say that this chemical equation has been balanced. And I'm hoping you're understanding and getting the hang of it as I move along. And now let's move on. Now the next example that I have for you is this. It's CH4 or methane plus oxygen gives us carbon dioxide and water. This is the equation for combustion, and let's see how to solve it. So let's get on with the first step of our equation. Let's write down the number of atoms of each element. So on the left hand side we see that carbon has 1 atom, hydrogen 4, and oxygen 2. On the right hand side, carbon 1, hydrogen 2, and oxygen 3. Now let us take a look at what we have over here. It's an odd even case, at least that's what I call it. It's when on one side you have 2 or an even number of atoms, and on the other side you have an odd number of atoms of that same element. And this can sometimes be a bit tricky to solve, but what you need to do, and the easiest way to solve this, is basically to multiply the odd side, the side whichever has odd atom, with an even number such as 2 or 4, and any number basically that will give you an even number of atoms. Now this will be clearer when I solve the equation. So now let us start solving the hydrogen. Let us start solving hydrogen first. So over here we have 4 atoms, and over here 2. And I think you know what to do right now. You need to multiply this side with 2, which will give you 4. So let me put it 2 over here, and this gives us 4 hydrogen on the right hand side. So 4 and 4, the hydrogen is now balanced. You see that. And actually, I had another intention of starting with hydrogen first, because now if we look at the oxygens on the right hand side, it isn't 3 anymore. It's actually 4. So 2 over here and 2 over here. So now basically we've done what we had to do. We've multiplied this side oxygen with a number that gives us an even number instead of an odd number. And now we have 4 oxygens on the right hand side. So now all we need to do, it's really simple, we've done this before. All we need to do is multiply this side. We need to multiply this side with a number that will give us the same number of oxygens on the right hand side. And that number is 2. So let's look at the oxygen over here, and we'll just write it 2 over here. And that's it. We've balanced this equation. It was pretty simple, I think. And let's just recheck if everything is balanced. So carbons have always been balanced, yes. Hydrogen 4 over here, both are balanced. And oxygen, let's see, 4 and oxygen 2 plus 2. Don't forget to count both of them, because sometimes you may only look at this side, or you may only look at this side and think that it's balanced or not balanced. Make sure you look at the whole equation and count all the oxygens in each of the elements and molecules. Now that's done, and let's move on to the next example. Now the next equation that I have for you today is this. C2H6 plus O2 gives us H2O plus CO2. Now we've solved quite a lot of chemical equations by now, and this one I'm going to be doing without writing the number of atoms over here. However, I'll just still keep this on in case we want to write it at any point of time. However, let's just solve it mentally, keeping the number of atoms mentally. So now on the left hand side we can see that we have 2 atoms of carbon, while on the right hand side we have only 1 atom of carbon. So I would multiply 2, I would keep a 2 over here as we've discussed before, and now the carbons are balanced for now. And then we have 6 atoms of hydrogen over here and only 2 atoms of hydrogen. And now we need to multiply these 2 atoms of hydrogen with a number that will give us 6. And we've all learned math. We need to multiply it with 3. So now we see that the carbons and the hydrogens are balanced. However, let's just take a look at oxygen right now. And right now I want to write down the number of oxygens on each side. So on the left hand side we have 2 oxygens. However, on the right hand side we have 3 plus 4, 7 oxygens. And this is kind of like a big number difference. It's an odd even combo, and it's a quite big number difference. So now what you would probably be thinking of is multiplying this side with a 2 or a 3 or a 4 to try to make it even, like I've said before. However, we see it's not only the oxygens that have been balanced, it's also the hydrogens and the carbons that we need to consider. And if we do multiply this side with any numbers, it could affect this side as well, and that would get kind of complex and kind of confusing. So an easy way to do this, probably the best and easiest method to do this, is to multiply something over here. And now you may be wondering how you can multiply it, as 2 is a smaller number than 7. But if you want to multiply 2 with a number that gives us 7, it would be 3.5. It would be 3.5, or let me write it as 7 by 2 into 7 by 2, and this would give us 7 because 2 and 2 gets cancelled out, and hence the oxygens are the same. So I'll be writing 7 by 2 over here, and at this point you may be confused as to whether we can actually do this, and the answer is no. You can't actually write a fraction as the coefficient. We always want whole numbers. We don't want 7 by 2 molecules of oxygen. We want 3 molecules of oxygen. We want 4. But this is actually wrong, and you can never write a fraction or a decimal or any other thing that's not a whole number in place of the coefficient. So now, how do we remove the bottom 2 denominator and make it a whole number? Well, we've already done before. The answer is right in front of us. We multiply the whole equation by 2. Well, the reason we have to multiply the whole equation is because if we only multiply this equation, then it won't be 7, it would be 2, and I've already talked about multiplying stuff over here. So we multiply the whole equation with 2 to cut off the effects of the denominator. So now what we do is multiply the whole equation by 2. So this 2 into 7, this gets cut off and we have only 7 remaining. And instead of 3, this becomes 6. Instead of 2, this becomes 2 into 2, 4. And now let's check if everything's in place. So carbon 4 over here, carbon 4. Hydrogen 2 into 6, 12. Hydrogen 6 into 2, 12. And oxygen 7 into 2, 14. 14. And oxygen over here, let's see, 6 plus 4 into 2, 8. 14 as well. So we see that everything is balanced, and it's a pretty easy way of getting things done. And if you ever are stuck in a situation with this odd even combination and you know such a situation, you could always use this. It's a really easy method and it gets stuff done really quickly. Now let's move on to our next. Okay, so let's move on to our next equation. And I've chosen this equation precisely because it has a polyatomic ion in it. Over here we see that NO3 or nitrate is a polyatomic ion on both the left and right hand sides of the equation. And the thing with a polyatomic ion is, if you have a polyatomic ion in an equation and it's on both the sides, you can consider it as one. So we have written NO3 instead of nitrogen and oxygen separately. You can consider it as one. For example, over here I would say that we have 2 nitrate ions, and on the right hand side I have only 1 nitrate ion. However, you can only do this if the nitrate ion is on both the left and right hand sides of the equation. For example, if the nitrate ion was only on the left side of the equation and during the reaction nitrate got split and nitrogen became separate and oxygen became separate, then I wouldn't be able to consider it as a nitrate ion. I would have to consider nitrogen and oxygen separately. However, since it's together, I can consider, nitrate ion as a whole. Even if you want to do nitrogen element and oxygen separately and go ahead with solving it like that, you can. It would be, but it's just easier to consider 2 nitrate ions and 1 nitrate ion instead of 2 nitrogen atoms and 6 oxygen atoms. So I hope you do get the point, and let's move on with solving our equation. And just like last time, I won't be writing the atoms down over here. I'm just going to be keeping all the number of atoms and elements mentally in my head. So over here we see that silver is has one atom of each on both the sides, so silver is balanced. However, we see that we have two nitrate ions on the left hand side and one on the right hand side, so I'll be balancing that by putting a 2. And since we've done that, now Na or sodium has 2 on the right hand side but only 1 on the left hand side, so let's go ahead and balance that as well. Just put a 2 over here. And this was pretty much a simple equation. You see that everything is balanced right now. This is 1 1 NO3 2 2, sodium 2 2, and since you put it 2, Cl has already been balanced, chlorine has already been balanced, so that's also balanced off. And all I wanted to show you was about the nitrate ion. Otherwise, this was a pretty simple equation, and I hope you do get it. Thank you. Thank you so much for watching this video. I hope you do like it. If you did, please do like, share and subscribe to our channel. We have lots of videos uploaded, and part 3 of chemical reactions and equations will be coming out very soon. So make sure you do check that out. Thank you so much once again for watching this video, and bye.